Hello everybody and welcome to today's XP Live webinar. My name is Nicole Highlander and I'm the marketing manager here in the XP Solutions Portland, Oregon office. Today's webinar is exciting for us here at XP because it's going to be the first look at the 2017 version of XPSWM and XPSTORM. For those of you who may not be familiar with XP Solutions, we have a long history of providing high-performing software solutions. Our intention is to make sure that in your work, you can model with confidence. Now, this means that we strive to provide excellent customer service and support around the world, and that we offer continuing education opportunities for engineers in our industry, which is part of the reason that we provide these regular webinars for you. Now, on to our presentation. Today's presenter is Tony Kuch, our Vice President of Client Services and Product Owner for XPSWM and XPSTORM. Tony's been with XP Solutions for over 23 years. He's trained thousands of XP users, provided technical and engineering support, and continues to drive the development of XPSWM and XPSTORM. Tony is our XPSWM guru, which means that today you are in very good hands. Thank you for joining, and here's Tony.
Thanks, Nicole, especially for the kind introduction. Today, my agenda is essentially that I'm going to set out and start presenting the software, and I'm going to present it in a way that takes advantage of the productivity tools that are in the software. I want to display, especially to any new users and even those that are somewhat experienced, that it's very efficient in our software to build a stormwater model. And I'm going to do it in such a way that I believe you will agree that it's very easy to start building models. In that process, I'm going to be demonstrating a lot of the new features of 2017.1. And after I've done this demonstration, I'm going to further take some time and explain some of these new features in a more comprehensive way rather than just simply demonstrating their use. And I'm going to close the webinar with a discussion about templates. I'll say just now at this point that a template is an XP database file that acts as seed information and can make the use of XPSWM more productive when there's any kind of repetitive or commonality between one model and the next. I'm going to set this up with the challenge. So perhaps you noticed in the title of this webinar that, or in the subtext, that there was a challenge on, can I actually build a working model, a stormwater model in 5 minutes? I won't tip my hand per se, but let you know that I'm a little bit challenged to do it in 5 minutes because I'm one of the key trainers of the software, and I really narrate a lot about what I'm doing and how I'm doing it and why. And anyway, I may do a little bit less of that today so that I could be as efficient as possible in the software and give you a feel for, as an experienced user, what would that be like. And I'm going to set out on this challenge by using a template. So the template's going to be key for me to have different things sort of set up, like tables for viewing the data, etc. I'm going to switch to what we call a 1D mode or a sanitary wastewater mode. This is a new feature of the software that will shrink the complexity of the interface for those that aren't doing 2D modeling. For example, those things will be made disabled or invisible, or it will just streamline. It's really a further enhancement of the software that we did with river modeling in the past, where we've created river links and bridge links, so that if you are using our diverse product and your applications are really well varied, then you can do things in the beginning to streamline the product for the type of modeling that you're doing. So in this case, it would be simple 1D models. I'm going to import data from GIS, LandXML, and Excel. Those are pretty common formats and would be the experience of most users, and so you'll be able to have that as set out as well. And I'm going to have GIS catchments which are not yet associated with nodes. We have a feature in the software, it's not new to 2017, but it is fairly recent. It's called catchment drainage, and I'm going to be able to use this tool to automatically assign a catchment to a downstream target node. And for some model data, because I'm going to have a digital terrain model in this challenge, I'm going to use it to populate data. For example, the ground elevations of every node in the model could be derived by their location on the digital terrain model. So what do I have to start this? Well, here's my data summary. I've got an aerial image with a world file. A world file is a file that allows the background image to be located at the correct coordinate system so that it has the right scale and so on. In the same coordinate system, I have topography, or if you will, elevation data. I've got this in a text file of X, Y, and Z, and that's going to help me later to derive some data in the model. I've also got some GIS polygons, and I have a GIS set of nodes or points which represent the outlet nodes for each of these catchments. My data also includes an XP template, which I mentioned. It's going to help me set some model defaults. For example, setting the hydrology routing method and maybe even a default curve number. And then the template is going to also have a profile plot setup, some XP tables that I might take advantage of, even my design storms stored in the global database as rainfall data. Finally, I've got an Excel spreadsheet that has the conduit information, but I also have this in a land XML file. So the hydraulic network in Civil 3D, for example, can be exported to land XML, and XPSWM can import that land XML. XPSWM, XPSTORM also export land XML. And in the same Excel spreadsheet, I've got a hydrograph that is from off the site, which passes through the system. So this is the data that I have, and can I do it in 5 minutes? Well, I'm curious on what people think, so let's take a poll, Nicole.
Thanks, Tony. I've launched the poll, and Tony kind of gave a little hint earlier, but we'll see how long it takes him. Do you think he's going to be done in 5 minutes? No problem, because you know Tony's pretty good at XPSWM. Or is it going to take him a little longer? You guys choose, and then we'll see how this turns out. I'm going to go ahead and close that and share. So it looks like 56%, which is almost exactly the same as it was earlier today, think that it's going to take him 6 to 10 minutes. But a good portion have confidence in you, Tony, that you can come up to the challenge.
All right. Well, it is a challenge. Yeah. So
thanks for everybody.
All right. Yes, thanks so much. So let's model. Nicole, I guess what I'd like you to do, if you don't mind assisting, if you could maybe start a timer, and once I start the process of creating a new model from a template, maybe that's when you could start the timer, and then let us know when we're done how long it actually took to build a stormwater model and complete the model results.
Absolutely. I have my smartphone ready to go. Do you want like if you get to 5 minutes, do you want me to let you know that?
Yeah, that would be fine. Just let me know about 5 minutes if I haven't finished in 5 minutes.
Okay, tell me when to go.
All right, so I'm going to create from template and choose continue. So Nicole, you can start the timer. I'm going to just choose the default name here, save that, and then pick the template from the templates folder. I'm going to switch the software, as I had mentioned, to the 1D wastewater sanitary mode, and that's collapsed my layer control panel, and it's removed some things that aren't necessary. I'm going to start by loading a background image by right click. I'm loading the background image from my webinar folder. The world file automatically brings in those eastings and northings, and I'm going to make it partly transparent. You know, you can make a bit of a watermark out of that. The topography holds the DTM, and a right click on the DTM will allow me to bring in the surface data. It's a text file of easting, northing elevations, and it has the ability to be shown as a constant color fill of various amount of transparency, or I could simply switch it to 5-meter contours, or 5-foot contours rather. I'm going to right click on the catchments, and I'm going to bring in my GIS catchments. I'm going to bring in the GIS catchments without bringing any data to them. I could, for example, bring in the curve number, but I'm going to have that assigned a different way by using what I call the model defaults, which are set under file properties. For example, curve number 65 and SCS hydrology are my defaults for my subcatchment number 1. Now I will load the corresponding GIS file of model nodes, and I'll set as the only attribute for them the name, which can be up to 80 characters alphanumeric. I'm going to make the nodes that are downstream of the catchments the only active objects by employing the replace feature in mode properties. Now these catchments are not yet associated to nodes, but I can employ the tool under calculate node, catchment drainage, which by rules allows me to set the downstream or the associated node to the catchment by, for example, nearest the vertex, and here I'll choose directly all nodes in model. I now have the catchments associated to the nodes, at which point I could go into the calculate node, and at this point, now that they're attached, I could calculate their area. I've calculated their area, and I can click the OK button, and I've got those areas now calculated. I'm going to save my model. Figure it's a good point. I'm going to set up 3 global storms. Global storms is a feature that allows you to do a batch of storms. In fact, new to 2017 is that this can be populated, or this dialog can be populated with a copy from Excel or some other program and paste to populate this table. I've got 10, 25, and 100-year return period SCS type 2 design storms. I need to now just set some local data that I haven't imported. For example, at the most upstream node, I'm going to put in a time of concentration of 15 minutes. For the second subcatchment in this dialog, I'm going to again use curve number 65. I didn't have this default set. I had it only for subcatchment number 1s. And I've set the time of concentration for that one as well. At node 2 now, I'm going to set my time of concentration for this node to 45 minutes. And for the final node, the data requirement is simply the time of concentration again at 35 minutes. I believe I'm ready to solve for hydrology, so I'll click on the solve icon. And you can see it doing 1 out of 3, 2 out of 3, and 3 out of 3 catchments. Sorry, well, 3 catchments, or nodes, and then the 3 design storms. I could review results, and I can clearly see for each of the nodes I've got 3 time series which I'm comparing from my simulation of global storms. A new feature in 2017.1 for XP is a solve manager. The solve manager allows all of the storms to be solved simultaneously. It's for parallel solving.
5 minutes.
So thank you. I've solved now for the hydrology. I guess I got that part done in 5 minutes. And here's the results, but I guess I just want to make the point here. I suppose it's costing me time, but I've solved it now in parallel. If I have a multi-core computer, I can solve in parallel. Let's switch now to the hydraulics mode. I've switched to hydraulics. I'm going to make all of my nodes active, and I'm going to generate these ground elevations from the tin. Here's all the corresponding elevations where the nodes are located, and I've set the ground elevations from the tin. I can either use my connection through to a spreadsheet that has the conduit data to bring in. I've mapped things. It could be remembered as even part of a template. Or in this case, I think what I'll do is show the import of LandXML. So I'm going to bring in the model network through LandXML. Now I have all of the links and nodes with their corresponding, let me just click on a link here, with its corresponding data like diameter and inverts. Let's set the final node to a free outfall. You can see some of the new graphics in the dialogues that we've done for 2017. And at the most upstream node, I'm going to simply copy and paste a hydrograph from Excel. I'll click the OK button. There's a little preview of the graph. And at this point, usually when I import data, I usually like to make sure that all of the node inverts are equal to the lowest connected link invert. That's one command in the modify elevations that can just make sure that there are no pipes coming in below any nodes. I'll save, and I'm going to finally solve for both the runoff and the hydraulics of my model, and I'll solve. Oh, I've missed a step here. Yes, in the runoff mode, when I imported, well, let's see, what? Yes, I'm missing a couple of nodes not active. There we go. I just pressed the plus on the keyboard. Well, what else am I missing? Yes, in the runoff mode, here I am in runoff. I need to make sure all of my links are inactive in runoff, and then I'll be able to solve. All right, so we're solving. Well, this was a place where I probably should have used the solve manager, because I would have solved this 3 storms at the same time it would have taken me to solve one. So let's just do that now. Choose the solve manager, solve all of these at once. I have an 8-core computer, so I could do 8 of them all at one time. I'll close these dialogues, come back, show you the hydraulic results, and then I'll get Nicole to tell me what the time was to be able to get to this point where I'm showing hydrology and hydraulic results in a stormwater model. All right, Nicole, what was my time?
That was pretty fast, 8 minutes, 37 seconds.
Well, I couldn't do it in 5 minutes. I still find myself too talkative. So, all right, well, not bad. I do have other things that I'd like to show you, but maybe at a pace that's not trying to race the clock and show you how efficient XP could be, but rather explain some of the other new features in a little bit more detail. So the next thing I have planned to talk to you about is a change to the program's editor. Under Tools, Application Settings, Main, you can set a text editor for XP. The text editor by default is Notepad++. So for 2017.1, we actually added the most recent version of Notepad++, and I'm just going to load a couple of the text output files. One more I'll load up, let's say the 10 and the 100. So now in Notepad++, we also have loaded it with a compare plugin. So there's a plugin called Compare that allows you to take 2 text files and compare them in some detail. So using this arrow down, I could go to the next difference, the next difference. For example, here it's highlighted that in one case it was 3.2 inches of rain, and the next 7.1 inch from the 10 to the 100. So this ability to compare text files is really useful in global storms or scenarios or 2 similar models two totally separate similar models. There are other tools that are possible. I showed you can choose your own text editor. Ultra Edit is one that I personally use, although there's a small fee for it. I believe it's under $100 to get Ultra Edit and Ultra Compare. All right, so I'm going to just do a few changes to this model in order to show you some more new features. So let's just simplify this down to, say, one global storm. I've just unticked the others, so now I'm only going to be solving the 25-year. I'm going to import a branch to this model. Under the File, Import, Export Data, Import Land XML, I'll be bringing in the branch network. So here I have a branch. I'll make sure it's not active in the runoff mode. It doesn't have any hydrology data behind it, but I will give it a constant inflow in the most upstream node. Now, before I solve, if I was to show you in, say, the dynamic long section or the profile, I've imported this and it has matching inverts to the existing system. Well, I will save this view. When you save a view and you have highlighted objects, they're also saved. So I'll call this part branch, and I'll call the rest of the network just network. So I'll save two views, one branch and one network. If you wanted to switch to one selection versus the other, you could go to restoring the views, and I'll pick the branch again. Well, a new tool in 2017 is in Modify Elevations that you can match crowns or match inverts. These selected objects are currently matching the inverts, so let's match the crowns. I'll do that by adjusting node and link inverts. I get the message that 4 were adjusted. So if I show you the profile now, it will have matching crowns. It did that by lowering the downstream links to match the crowns. It did that solution from upstream to downstream. And the reverse can happen. I can match these inverts now by working from the downstream to the upstream, making that kind of a design change. A lot of sanitary sewers will have matched inverts, and a lot of storm sewers will have matched crowns. The node here that joins the two, I guess you could call this the junction node, I'm going to use a tool in Modify Elevations to set the node invert to the lowest connected link invert. Because link 3 got lowered, this node needs to be adjusted, and so I'll set that. And I've made this now. I'll save because I'm about to solve, and I can solve the model. If I was to review results, for example, for this downstream link, I can see the hydrograph. And maybe another point I'll make, if I was to zoom in, you can see that the first point, and right-click undo zoom, and the last point are part of the displayed time series. This is actually new to 2017.1. Previously, the first and last points weren't part of the time series. So in 2017.1, we made the change that those first and last points are available. Another key feature to 2017.1 is related to a tool called Profile Plot. The Profile Plot in the past worked on selecting a string of links and nodes, and only one plot per page was permitted. This new dialog allows you to, say with the control key, select multiple saved views and their selection of objects, or one button to select all. So we're going to be able to put multiple graphs per page, or plots per page. And I can also choose to include the surface data. I have an XPTIN here, so as opposed to the past where a straight line would have been drawn from the upstream node to the downstream node, now the terrain data that lies between the nodes is going to be part of my plot. So I'll click OK button now to go to the plot. I'll just for now allow it to be scaled to fit, and I'll click the OK button. You can see here multiple plots on the page, and as opposed to a straight line between the upstream node and the downstream node, the actual ground or the irregular ground elevation between the nodes can be displayed. This is showing me the invert of the conduits, the top of the conduits, the maximum hydraulic grade line, and the ground. That's the 4 lines that you're viewing. As far as changing these, where they're located on the page and their scale and organizing it, it's with the right mouse button. Here I am shrinking this one and maybe dragging it and moving it to another part of the view, or perhaps for plot number 2, I can move and adjust this one. So you can organize and arrange these by switching and dragging these around. So that's another key new feature for the software. That's all of the live demo that I had prepared to show you. However, I would like to discuss some of these new features in a less hurried pace and not as part of the challenge. So let me switch over to my PowerPoint presentation. The enhancements for 2017, I've demoed the Solve Manager, but these items that are in the blue box are ones that I'm going to talk about in a little bit more detail. The comparison in the Notepad++, converting the software to sanitary wastewater, or if you will, 1D modeling only. The profile plot, that it can hold multiple network segments, and this modify elevations to match crowns or match inverts. I also demoed, but I'm not going to explain any further today, the review results first and last points and the ability to copy and paste to the Global Storms dialog. But there were many other enhancements to the software, very diverse, from the ability to have an additional method of Horton for infiltration on 2D, all the way to perhaps you might say an expanded and improved reader of EPA swim files and flood modeler profiles. The Solve Manager was accessed from the Analyze menu. This Solve Manager essentially allows parallel solves. So all of your physical cores on your computer and the logical ones are allowed to be used to spawn a swim run. So for example, I'm using my laptop right now. I have an 8-core i7. I could theoretically solve 8 models at the same time. If you had a bigger list than that, then once one of the cores is free, another model run is teed off. So you could assume with an 8-core computer then up to something like 8 times faster for the total simulation of all of the runs. This is really an ideal tool for Scenario Manager and for global storm runs. But it has a couple of dialogues that allow you to, if you wanted manually to pick which input file to the engine, which engine you wanted to use, like 64-bit or 32-bit engine, you can toggle them on or off. And then another dialog, the engine viewer, gives different messages from the engine, like when it was started, when it was stopped, etc. The Solve Manager is essentially a little bit of a paradigm shift from a consecutive set of solving, as you can see here, like 2 out of 3. If you had 3 storms, it would just run them in a consecutive batch, to what I would describe as a concurrent solve. So instead of consecutive 3 storms, it will do all 3 at the same time. You know, the caveat is you'd have to have a computer that's got at least 3 cores for that to happen. So, 2 out of 3 to 3 1 out of 1s. Hopefully that's well explained, and you get the idea about how this could really be beneficial for any kind of multiple runs. The Notepad++ Compare plugin, you could say that what we've done is we've updated the software to the latest version of Notepad++, but not only did we do that, we loaded it with its plugins, and the key one that I'm highlighting for you is this comparison plugin, because it allows 2 files to be compared. Let's say you wanted to compare more than two, or you wanted an even better text editor. I would say Ultra Edit and Ultra Compare are really excellent third-party tools. You just go to your application settings and you could point it towards Ultra Edit, which actually I do on my own computer. And then, you know, in Notepad++ or in Ultra Edit, you can compare files, but Ultra Edit allows a comparison of 3 files. Now, the sanitary sewer wastewater switch, you know, is from the configuration menu. It's at the bottom. It defaults to stormwater, but you can convert it to this wastewater sanitary, which I might contemplate changing the name because it really just means that you're switching it to 1D only models. Of course, most wastewater sanitary models are 1D. So one of the changes is that it would convert your layer control panel to this large list, including things like grid layers of 2D model, to a more simplified approach where things that aren't appropriate for sanitary, wastewater, or simple 1D models will collapse down to this, and in fact these other things are grayed out. Other changes happen, like tools on the toolbar as well get removed or disabled, and even the units dialog changes. So as soon as you're into wastewater sanitary, you're allowed to choose the flow units. And so this means that the model will report the flow units, for example, in million gallons per day or liters per second, rather than the default cubic feet per second or cubic meters per second, depending on your US customary or metric units. The Modify Elevations dialog has 2 new items: the match crowns, which means the top of the conduit are all matched in elevation as you go from the upstream conduit to the downstream conduit through a node. And you can automatically select objects and choose match inverts, which would allow all of the invert elevations of the system to have a match. The convention in a stormwater model would be typically to match crowns, and in a sanitary sewer model would be to match inverts. So you can quickly change this. I would say it's a good follow-up tool after you do a design in our software. So if you turn on the ability of the software to automatically size pipes, then you may want to align their crowns or align their inverts, have them be a match, and then analyze the system and see how it performs. So it's a good follow-up to a design run. Now the profile plot, which can be accessed through the results menu profile plot or pressing F8, that's the keyboard equivalent. It's basically brought up a new dialog called profile plot, allowing you to select any stored views, and of course there's selected objects, and an option to turn on the surface data. So this is giving me, as you can see on this picture, multiple per page. I just have an example of 2, but you know, it could be 10 or 8. You know, that's just, I don't know of any limit. And you can see the ground elevation that has come from the XP tin as well. So those 2 things are new. Previously, you'd have a straight line between the top of nodes, and you'd only be allowed 1 graph per page. The profile plot, once it's launched, you can then, with a right mouse click, manipulate these, changing their scale and changing their order through the combo box first, and then right click, drag, pan to move these things around and organize them. Then you would export it to DXF, and then perhaps in AutoCAD or MicroStation you might be adding your title block, etc. to go with this. Not only did we enhance the software, but we had a significant effort in maintenance this year. I'm not going to worry too much about this list, although this list gives you a little bit of an idea of the diversity of things that had happened. I did select a set few of these to give you a little bit of a feel on what our focus was for this major version. You know, the team literally created hundreds of small but significant changes to the software. For example, one example of the maintenance would be to address the user experience of creating global storms or scenario names. In the past, you were able to create a name which would be problematic for storing the results because the results files are your project name underscore global storm or scenario name, and we didn't prevent people from creating names that were invalid file names. So what we've done in the software now is we check the name and we'll give an error message if the name is invalid. So in this case, you would have to click this OK button, change your name so that it would be a valid name. And then, of course, you'd be able to solve, and you wouldn't have any kind of a crazy experience like can't find the results or something like that. Another example of the maintenance, which is all about the ability of the modeler to understand and retrieve information from a simulation. This is an example of 2017.1's WEIR review results or time series. In older versions, you would have had upstream elevation, downstream elevation, flow, and then a velocity time series, which always would have been 0. The thing that happens in the software for SWIM is we don't calculate a velocity for the WEIR. We only calculate its flow, and hence in the past, there would have been a 0 velocity time series. So we suppress that now, so as not to make a time series that's misleading in any way that we're presenting that it had 0 velocities. That'd be another example of what we're doing to make the program better. Another example is about the speed of use of the software. You know, it's kind of a thing that I was like teed up this whole webinar about, right? Can I do it in 5 minutes? Well, 10 minutes probably would have been a better target since I didn't quite make the 5-minute mark. To make the data entry faster for a user inflow time series, as soon as pollutants are turned on, in the past, the dialog would have had individual fields for the time, the flow, and each of the concentrations of pollutants. This did not accept copy-paste except for one cell at a time. That would be really tedious, right? But what we did, we changed the software so that this dialog would turn into a grid, and so all of these numbers here could be copied and pasted at one time from, say, an Excel spreadsheet if you happen to have time, flow, and then your pollutant concentrations. So, just another example. And finally, I've got one more after this. So, second last one, to give you an example of what we've been doing in the program. We've enhanced some of the dialogues. We've updated the pictures. You might say, why are we updating pictures? Well, we updated the pictures for all of the ones that we felt could be improved. You know the saying, a picture is worth 1,000 words? Well, we wanted the pictures to enhance the experience so that people really had a good understanding of what the data represented. So you'll notice that in this new version. We also made some updates to the text in dialogues. One example would be, if I go to the right one here, previously this would have said initial depth and then pump starts, pump stops. Users, especially new users, were unfamiliar that this information happened to be elevation or depth fields. So we're explicit now. We say that this is the pump starts elevation, and that removes some ambiguity and raises the user experience. Finally, the dialogue in the middle, it's a little bit humorous, but the dialogue was actually too big for people that were using low resolution monitors. So in fact the OK and cancel button may have been off the screen. It wasn't tragic. I mean, you can always press enter or escape, which map to the OK and the cancel button, but we've made the dialogue smaller so that if you're using a low resolution monitor, you know, below the minimum spec that we specify for the software, you would be able to at least see all of that dialogue. And finally, I have another example of some of the kind of maintenance that went on in the program. we're exposing more fields wherever appropriate. This is the before dialog on the left and the current one on the right. You'll notice that the downstream and upstream invert elevations are now appearing for the culvert as part of the bridge link. That's where this dialog comes from. So before, you had to go elsewhere to get this information. It's more appropriate to see it here, and so we've added and exposed those fields for any rectangular culverts as part of your bridge link. The software has this ability for many, many versions now called templates, and I still find, as the XPSWM product owner, that this is an underutilized feature. A template, let me just give you the definition, I guess. It's essentially any kind of XP database file. It has a T at the end. There's no difference. Like, it has XPT extension, but it's basically an XP database. Now, what do you use it for? It's really acts as a seed file to give you things like model defaults or global data like rain or XP tables, which actually I used it for. Even job control information. Anything an XP file can have, a template can have. So if you start from a template, then perhaps you are well on your way for doing any kind of repetitive work. Like if you are doing a stormwater model for the city of San Jose, and you know you're going to do several of them, if you spend a little time on the first one, then you can leverage all of that effort by using a template for the next one, and the one after that, and the one after that. It's really an excellent productivity tool. It can provide some uniformity amongst many users. So you've got several people that are going to be using XP. If everybody starts with the same template, then you can embed into this template all your organizational standards. Let's say you have a special drawing format in CAD or GIS for a catchment polygon or for a land use of buildings. Well, that can be duplicated in the template, and then whoever is doing XP modeling starts with the template. Everything's all uniform, and you're going to be able to as a reviewer, let's say, have the same expectation all of the time as you get models, and it's not going to be hard for you to review because everybody started from the same base. The template is further supported in the software by having a default template. I chose to use a specific one, but under the file menu you can create a new model from a default template. And this default template can be user specified. I mean, we ship a default US and a metric one, but feel free to take an existing model, save it as a template, and then in the INI file or the tools application settings, go and specify this to be your default template and get your own organizational standards as the default in the program. The templates are stored in a folder in the typical install. There's, XP 2017.1 templates folder. That's where the software defaults to looking for them. But they can also be downloaded from the XPSWM XPSTORM Resource Center. Perhaps some of you are unaware that this site exists, but it's help.xpsolutions.com. There's a section for each of our software titles. If you go to, say, XPSWM or XPSTORM, you're going to be able to find a section called Resource Downloads. And in the Resource Downloads, there's a Model Templates. There's a link here called All Templates, which would allow you to download all of them, but we also allow you to go in and specifically grab templates that belong to a certain region or a certain type of modeling. We'd definitely encourage you to do that. And we had envisioned with this help.xpsolutions.com, this is a wiki, we'd envisioned that other people may contribute. And it's been something that's been on my mind as the XPSWM and XPSTORM product owner. how about opening this wiki up to allow other people to contribute? All right, I'm basically finished with the information that I wanted to present about the latest version of XPSWM and XPSTORM. I really appreciate everybody's time. You know, we have a real big ongoing series of webinars, and some of you have attended many and make a good habit of joining us on our educational webinars. We have a couple that are coming up in February. February 1st, in fact, is the first one, called Data Preparation for Flood Modeling. We're going to have our storm and flood product manager, Matt Anderson. He's got a lot of experience in Civil 3D and in GIS in preparing data for modeling, and he's going to do that one and share some great insight for you. So be happy to have you join us for that. And Zach Sample, our stormwater management product manager, he's going to be using XP drainage and talking about the commercial constraints for pervious solutions. He's going to use a live, real project that was performed here in Portland, Oregon, and be able to present and talk about that with you. So definitely interested for you to join us. You can see the red links if you'd like to register. Those are how you would register, but you know, you could also go to our website and click on links to register. But if you can remember those simple links, essentially xps.link and then data prep or pervious.
Thanks everybody for your time, for your interest and excitement about XPSWM and XPSTORM 2017. We hope you enjoyed today's presentation, and we also hope that you enjoy the new version. Take care.